So, students, again we have one more class and that will be the last topic of the chapter matrices. And this is also a very interesting topic. I hope all of you will enjoy and do the questions along with me. It is a very important section and it is, take the subheading, elementary operation. Elementary, elementary operation, or it is also called transformation. Transformation of a matrix. Elementary operation, transformation of a matrix. Now, transformation means changes that you can make for a matrix, and in a matrix you have rows and columns. So that means the changes, transformations you are making for the rows and columns. For example, let us consider a matrix A is equal to 1, 2, 3, 4, 6, 9, minus 1, 0, 6. It is a square matrix of order 3. Now, for this matrix, elementary operation or transformation, I have, what are the operations I can do on this matrix? I can interchange two rows, any two rows, or I can interchange any two columns. Rows, I will mark it as R1. In the first class, I have said you R3. Columns, I have marked as C1, C2, C3. Now, I want to interchange R1 and R2. I want to interchange, switch. I want to switch R1 and R2. That means the notation I will use is R1 and R2 is interchanged. R1 and R2 is interchanged. Now the matrix becomes C is equal to matrix 4, 6, 9, 1, 2, 3, minus 1, 0, 6. This is called transformation. That is, you are making some changes. And when you make some change, whatever change you are making, you have to write before writing the matrix. R1 and R2 are interchanged. Similarly, you can use this for C1 and C2. What does this mean? Column C1 or column 2 and 3. 2 and 3 I can interchange. That is equal to X matrix. It is equal to 1, 4, minus 1, 2, 3, 2, 3, 3, 9, 6, 2, 6, 0. So, this is the way you can interchange the matrix. Now, scalar multiplication I can do. Transformation, change. That is, first row I am multiplying by a scalar quantity 1 by 2. It is equal to Y matrix. What is it equal to? 1 by 2, 4 by 2, 1 by 2, 2 by 2, 3 by 2, because I am applying on R1. 4, 6, 9, minus 1, 0, 6. So, these are all transformations on matrices. And after that, you can add or multiply or subtract whatever it is. Now, what is the use of this transformation of matrices? Because you are just finding out the transformation means it has an application. What is the application? The application is you can find the inverse of the matrix. Inverse of a matrix. So, suppose if there is a matrix A, the inverse of the matrix is denoted by A raised to minus 1. So that is the application of transformation of matrices. You can find the inverse of a matrix. Whenever you have a matrix A, you can find the inverse of the matrix. Later on, you can see that there are different methods to find the inverse of the matrix. Under this section, it will come as find the inverse of the matrix using transformation. Then you have to apply this method. Or suppose if it comes as find the inverse of the matrix means you are free to choose any method to find the inverse of the matrix. But when it is specified as find the inverse of the matrix using transformation, you have to use this method. And there are two types of finding the inverse of the matrix. The transformation can be either row transformation, or it can be column transformation. When I say transformation means you are getting the word change. Okay, fine. But what about row transformation? Throughout the question, you have to make changes only in rows. Throughout the question, you have to make the changes only in rows. And column transformation means you have to make the changes only for columns. And you have to discuss how to find the inverse of a matrix using row transformation and column transformation. Later on, there are many other methods to find the inverse. But if the question comes as find the inverse of the matrix using row transformation, you have to apply this method. So, answer according to your question. Now, before that, we have to discuss some theorems based on it. Proof is not required. Proof is given in your textbook. You can read those. Simple proof is given. Invertible matrix. If A is I am reading it. If A is a square matrix of order M, then there exists another square matrix B of the same order M such that AB is always equal to BA, and that is always equal to the identity matrix. That is always equal to the identity matrix. Then in that case, B is said to be the inverse of A. B is said to be the inverse of A, and it is denoted by B is equal to A inverse, read as A inverse. So, if there is a square matrix A of order M, there exists another B matrix of the same order, then the property says that AB is equal to BA is equal to the identity matrix. In that case, B is said to be the inverse of the matrix A, and it is denoted by A inverse. Now, second property is that if inverse exists, then it is unique. If inverse exists, then it is unique. So that means there is a key point in that property. If inverse exists, so there are cases in which inverse may not exist. So you have to understand, for all matrices, inverse need not exist. So some matrices inverses will exist. For some matrices inverse will not exist. But if at all inverse exists, then it is unique. Unique means, what is the meaning of unique? One and only one. If there is an inverse, it is only one for that matrix. Another property is that if A and B are invertible matrices, if A and B are invertible matrices, that means you can find the inverse. A and B are invertible matrices of the same order, then very important property, AB the whole inverse is equal to B inverse into A inverse. B inverse into A inverse. You may be asked to verify this. So you have to take the LHS, find the answer, take the RHS, get the answer, and you have to show that LHS is equal to RHS. So once again we will come through the three points. If there is a matrix A of order M and another matrix B of order M, then we can find in such a way that AB is equal to BA is equal to I, then B is said to be the inverse of A, or B is equal to A inverse. If inverse exists, for all matrices inverse need not exist. If inverse exists, then that inverse is unique. And the third one, if A and B are invertible matrices. What do you mean by invertible matrices? Invertible matrices means you can find the inverse of A and B. If A and B are invertible matrices of the same order, then AB the whole inverse is equal to B inverse into A inverse. Now, we come to the point. Okay, I hope you all understood the properties. Now, we are coming to the question. We are going to find the inverse of the matrix using row transformation or column transformation. Find the inverses. Find the inverses using row transformation. So transformation means change. Row transformation means change in row. Row transformation. So you have to find the inverse using row transformation. Transformation means change, and where have you to make the change? You have to make the change for rows. Let us take an example. Matrix A is equal to matrix 1, minus 1, 2, 3. We have to find the inverse of this matrix using row transformation. So when the question comes as row transformation, first you have to write A is equal to I into A. Row transformation. The important point is you have to write A is equal to I into A. I is nothing but your unit matrix, or not unit matrix, the identity matrix of order 2. So what is A is equal to? 1, minus 1, 2, 3 is equal to I. 1, 0, 0, 1 into A. So it is row. Changes are given to rows. Now what have you to do is you have to make changes in rows in such a way that LHS matrix becomes 1, 0, 0, 1. Once again I am telling you, the changes you have to make for rows in such a way that this LHS matrix changes to 1, 0, 0, 1. Whatever changes you are making for LHS, the same changes you have to make for RHS also. So here when you observe the question, It is a simple question. Already it is 1 over here. Minus 1. So this minus 1 should become 0. This 2 should become 0. 3 should become 1. How can you make that change? Now, first I will make this 2 as 0. So how can you do that? R2 is changed as R2 minus 2R1. R2 is changed as R2 minus 2R1. So for the first row, I am not making any change. 1 minus 1. R2. 2 minus 2 into 1, 2. 2 minus 2, it is equal to 0. Here, 3 minus minus 2. Minus of minus 2, minus 2 into minus 1 is 2. So, what is it equal to if you have a doubt? 3 minus 2 into minus 1 is equal to minus 2, which is equal to 5. The same change on the RHS you will make. That is 1, 0. What is it? R2. 0 minus 2 into 1. 0 minus 2 into 1 is equal to minus 2. R2. 1 minus 0. It is equal to 1 into A. Okay. Now 1, 0 has come. Now this one you have to make it as 1. Here you have 5. So what I will do? R2 divided by 5 is equal to 1 minus 1, 0, 1 is equal to 1, 0 minus 2 by 5, 1 by 5 into A. Whatever changes you are making on the LHS, the same changes you have to make for RHS. Keeping in mind the LHS becomes a matrix of the form 1, 0, 0, 1. Now what you have? You have to make the change for this minus 1. This minus 1 should become 0. How can I make this minus 1 as 0? What I will do is R1 is changed as R1 plus R2. R1 I am changing as R1 plus R2 equal to 1 plus 0, 1. Minus 1 plus 1, 0. 0, 1 is equal to the same change on RHS. Minus 1 plus minus 2 by 5. I will write here minus 1 plus minus 2 by 5. 0 plus 1 by 5. Minus 2 by 5. 1 by 5 into A. That is matrix 1, 0, 0, 1 equal to 1 plus minus 2 by 5, 3 by 5, 0 plus 1 by 5, 1 by 5, minus 2 by 5, 1 by 5 into A. So here you have made it into an identity matrix, and this identity matrix has changed to some other matrix. So this matrix is called as the inverse. A inverse is equal to 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. That will be the inverse of this matrix A. So this inverse I have found out by using what transformation? I have used row transformation. So when you say row transformation, at once it should come to your mind A is equal to I into A. Do you need one more question? Yes or no? Do you need one more question? Yes. Okay. One more question we will do based on row transformation. A is equal to matrix 2, 5, 1, 3. You are asked to find out the inverse of this matrix using row transformation. So what is row transformation? A is equal to I into A. This is your row. Keep in mind that you are making the changes for row. That is 2, 5, 1, 3 is equal to the identity matrix 1, 0, 0, 1 into A. Now, how can you make, your aim is this matrix should be changed as identity matrix. So, here it should be 1. So, I can make a switching over here. R1 and R2 I am interchanging. Or you want to, if you want, you can take R1 divided by 2. It's up to you. So, I am taking, because here you have 1, I am switching it. It is equal to 1, 3, 2, 5 equal to, what will happen over here? 0, 1, 1, 0 into A. Okay. Now, this one should become 0. R2 divided by 2, or I can take it as R2 is changed as R2 minus 2R1. So for R1 no change, 1, 3. R2, 2 minus 2, 0. 5 minus 2 into 3, 6. So 5 minus 6, minus 1 equal to R1 no change, 0, 1. R2 1 minus 2 into 0, 1. Next one, 0 minus 2 into 1, minus 2 into A. I have got two things, 1, 0. Then I have to get 0 and 1 over here. So what I do is R2 divided by minus 1. R2 divided by minus 1 is equal to, or I can write it as R2 into minus 1. 1, 3, 0, 1 is equal to 0, 1. Here it becomes minus 1, 2 into A. Now here I have 3. I should make it as 0. I'll change as R1 is changed as R1 minus 3R2. That is 1 minus 3 into 0, 0, 1. 3 minus 3, 0, 0, 1. So it is a identity matrix. And this is equal to R1. 0 minus 3 into minus 1, it is equal to 3. Then 1 minus 3 into 2, 6. 1 minus 6 is equal to minus 5. Minus 1, 2 equal to A. So LHS is equal to the identity matrix, and RHS, that identity matrix has changed to another new matrix. So the inverse, A inverse is equal to 3 minus 5 minus 1, 2. This is how you do the, or how to find the inverse of a square matrix using row transformation. Always make the LHS an identity matrix. Now, one problem we will do for column transformation. Write down the question. Find the inverses using column transformation. Unlike the row transformation, for the column transformation, you will take it as A is equal to A into I. Column transformation, and the changes we are giving to columns. A is equal to A into I, where I is the identity matrix of the given order of matrix A. So, here changes should be made given to columns. We will take a question. A is equal to matrix 1, 3, 2, 7. Using column transformation, you have to get the inverse of the matrix. So, I will write first A is equal to A into I. That is 1, 3, 2, 7 is equal to A into the identity matrix 1, 0, 0, 1. Here I have to make the identity matrix. Okay, here it is 1. Now this one I have to make it as 0. So what I will do is C2 is changed as C2 minus 3 into C1. C2 is changed as C2 minus 3 into C1. So column, first column no change. 3 minus 3, 0. 7 minus 3 into 2, 6, which is equal to 1. Here, first column as such, column 0 minus 3 into 1, minus 3. C2, 2 minus 0, 1 minus 0. It is equal to 1. A into I. So 1, 0. Now I have to make this one as 0 by taking a transformation on the column. C1 is changed as C1 minus 2 into C2. C1 minus 2 into C2. Observe it. C1. 1 minus 2 into 0. 0. So 1 minus 0 is 1. 2 minus 2. 0. And this will be 0, 1. Equal to, for C2, C1 I am changing. C1. 1 minus 2 into minus 3. That will be 6. 1 minus 1 plus minus 2 into minus 3. That is 1 plus 6 is equal to, isn't it? 1, 2, 7. Second column as such, minus 3, 1. Then 0 minus 2 into 1, 2. That will be minus 2. So LHS you have got as a identity matrix. So what is the inverse is equal to? A inverse is equal to 7 minus 3 minus 2, 1. This will be the inverse of the matrix by using column transformation. This is how you do. 1, 0, 0, 1 should be on the LHS. Now, suppose you are getting a question like find the inverse using transformation. Nothing is mentioned about rows or columns. It is up to you. You can either go for row matrix, row transformation, or you can go for column transformation. But if it is specified, find the inverse using row transformation or column transformation, you have to go for that method itself. For column transformation, you will write as A is equal to A into I, A into I, A into I. Whatever changes you are making on the LHS, you have to make it on the RHS also. Now find the inverse using transformation. I am not mentioning whether it is row transformation or column transformation. Find the inverse using transformation. So it's easy. I am applying row transformation. Take the question. P is equal to matrix 10 minus 2 minus 5 1. So here it's not an identity matrix. I'll go for row transformation, row, and I'll write P is equal to I into P. What is P? 10 minus 2 minus 5 1 is equal to I 1 0 0 1 into P. Okay. What I'll do is R1 I am dividing by 10. 1 minus 2 by 10 minus 5 1 is equal to 1 by 10 0 0 1 into P. Or I can write this as 1 minus 1 by 5 minus 5 1 is equal to 1 by 10 0 0 1 into P. So I have 1 over here 0 0 1. So these two elements are okay. Now I have to make this as 0. Isn't it? This 5 minus 5 should become 0. What I'll do is R2 is changed as R2 plus 5 R1 because it is negative 5 over here. First row 1 minus 1 by 5. R2 minus 5 plus 5 into R1. Here it is 5. So minus 5 plus 5, 0. Next one, 1 into minus 1 into 5 into R1. So 5 into R1 means 5 into minus 1 by 5. R2 plus 5 into minus 1 by 5. 5 and 5 cancel. 1 plus minus 1 is equal to 0. Equal to 0, and that is equal to 1 by 10 0. R2 plus 5 into R1. R2 0 plus 5 into R1. That is equal to 5 by 10. R2 1 plus 0 1 into P. But here I will say that inverse does not exist because the two elements in the second row, they are equal to 0. Elements of second row on RHS are all zeros. LHS are all zeros. So inverse does not exist. So I hope you remember the theorem. The theorem states that if inverse exists, if inverses exist, then inverse is unique. So there are cases inverse will not exist, and this is an example why inverse does not exist. The second row, all elements are LHS. On LHS, the second row elements are all equal to zeros. The same way in rows, you can have all zeros. That means inverse does not exist. So for all matrix, inverse need not exist. Do you want one more question?
Yes, yes.
Find the inverse using column transformation. Using rows, we have done 2. Using column transformation, find the inverse. B is equal to matrix 2, 1, 4, 2. So the question is using column transformation. So what is the first step I have told you? We have to take B is equal to B into I. That is 2, 1, 4, 2 is equal to 2, 1, 4, that is equal to B into I. 1, 0, 0, 1. I should make changes for columns. Now I have 1 over here. So what I'll do is I am switching C1 and C2. I am interchanging C1 and C2. 1, 2, 2, 4 equal to B into 0, 1, 1, 0. Okay. So now here it is 1. Here I should make it as 2, 0. So what can I do? It is column transformation. C2 I am changing it as C2 minus 2C1. C2 is changed as C2 minus 2C1. So 2 minus 2, 0. C2. 4 minus, what is this equal to? 4 minus 4. This is equal to 0. It's equal to B into first column as such 0, 1, 2C1. 1 minus 0 minus 2 minus 2. So what can you say over here? Inverse does not exist because 2 elements of the columns are all equal to 0. So inverse does not exist. So I hope it's clear to you. You can do now exercise 3.4 in your textbook, and with that chapter 3 matrices is done. And next week, today is Saturday, so next Wednesday you will have a test paper on matrices. Be prepared for that. Okay, thank you.